Morning.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Morning, sir.
I think this is the last problem we discussed in the previous class. All right. Y is equal to tan x.
Yes, sir.
Yes, sir.
Next one. Obtain the Maclaurin's expansion of log 1 plus sin x up to the term containing x power 4. That means you have to differentiate the given function successively 4 times with respect to x. Obtain the Maclaurin's expansion of log 1 plus sin x up to the term containing x power 4. Let this be y of x. Y of x is equal to log 1 plus sin x. All the functional values are required at x is equal to 0. So put x is equal to 0. When x is equal to 0, this takes the form y of 0. This is equal to log 1 plus sin 0. But sin 0 is 0. And 0 plus 1 is 1. And we get log 1. What is the value of log 1? Log 1 is always equal to 0. Therefore, we get y of 0 is equal to 0. Next, to find y1, differentiate this y of x with respect to x. Derivative of y of x is y1 of x. This is equal to derivative of log 1 plus sin x is 1 divided by 1 plus sin x into derivative of 1 plus sin x, where 1 is a constant, its derivative must be 0, and derivative of sin x is cos x. Therefore, cos x divided by 1 plus sin x is the first derivative. Now put x is equal to 0. When x is equal to 0, this will be y1 of 0. This is equal to, numerator will be cos 0 and cos 0 is 1. Divided by denominator will be 1 plus sin 0, but sin 0 is 0. 0 plus 1 is 1. 1 by 1. 1 by 1 is 1. y1 of 0 is equal to 1. Next, to find second order derivative, first we simplify this. 1 plus sin x into y1 is 1 plus sin x into y1, and RHS will be cos x. This is just to avoid quotient rule. This is not compulsory. As it is, you can use quotient rule and simplify, then also you get the same answer. But certainly this will reduce the level of difficulty writing like this. 1 plus sin x into y1 is equal to cos x. Now differentiate. First we shall differentiate this left hand side, keeping this function as first function and this function as second function. First function 1 plus sin x into derivative of y1 is y2. Plus second function y1 into derivative of 1 plus sin x, where 1 is a constant, its derivative must be 0, and derivative of sin x is cos x. This is equal to derivative of cos x is minus sin x. Put x is equal to 0. When x is equal to 0, this will be sin 0. Sin 0 is 0. 0 plus 1 is 1. 1 into y2 is y2. y2 means y2 of 0. This is equal to cos 0 is 1 into y1. y1 is also 1. Cos 0 is also 1. 1 into 1 is 1 plus 1. This is equal to sin 0 is 0. Therefore, y2 of 0 is equal to minus 1. y2 of 0 is minus 1. Next, we find third derivative. To find a third derivative, differentiate this expression throughout with respect to x. Treating this as first function and this as second function, we differentiate. First function 1 plus sin x into derivative of y2 is y3, plus second function y2 into derivative of 1 plus sin x is cos x. Because 1 is constant, its derivative is 0, and derivative of sin x is cos x. Now here, this is first function and this is second function. First function cos x into derivative of y1 is y2 plus second function y1 into derivative of cos x is minus sin x. This is equal to minus into derivative of sin x is cos x. That is 1 plus sin x into y3 as this cos x y2 plus cos x y2 is 2 times cos x y2 minus sin x y1 as this. This is equal to minus cos x. Now put x is equal to 0. When x is equal to 0, this will be 0. Sin 0 is 0. 0 plus 1 is 1. One into y3 is y3. y3 means y3 of 0. Plus 2 into cos 0. Cos 0 is 1. 1 into 2 is 2. Into y2. y2 is minus 1. Minus 1. And here sin 0 is 0. 0 into anything is 0. This is equal to minus cos 0. Cos 0 is 1. Therefore, minus 1. Therefore, y3 of 0 is equal to minus 1. This minus 1. 2 into minus 1 is minus 1. Transform this minus 1 to RHS. That becomes plus 2. This is equal to minus 1 plus 2 is 1. y3 of 0 is 1. Next, we find fourth derivative. To find fourth derivative, differentiate this expression throughout with respect to x. First, we shall differentiate this function. 1 plus sin x first function and y3 second function. 1 plus sin x into derivative of y3 is y4 plus second function y3 into derivative of 1 plus sin x. 1 is constant, its derivative is 0 and derivative of sin x is cos x. Similarly, 2 cos x is first function and y2 is second function. Second function y2 into derivative of first function 2 cos x is minus 2 sin x plus first function 2 cos x into derivative of y2 is y3. Similarly here minus sin x is first function and y1 is second function. Minus sin x into derivative of y1 is y2 plus second function y1 into derivative of minus sin x is minus cos x. This is equal to derivative of cos x is minus sin x minus into minus plus sin x. One plus sin x into y4. Cos x y3 plus 2 cos x y3 is 3 cos x y3. Minus 2 sin x y2 minus sin x y2 is minus 3 sin x y2. Minus cos x y1 as this. This is equal to sin x. Now put x is equal to 0 and find this functional value. When x is equal to 0, this will be sin 0. Sin 0 is 0. 0 plus 1 is 1. 1 into y4. y4 means y4 of 0. 3 into cos 0. Cos 0 is 1. 3 into 1 is 3. Into y3. y3 is also 1. 3 into 1 is 3. Here sin 0 is 0. 0 into anything is 0. Minus cos 0 is 1. y1 is also 1. 1 into 1 is 1. This is equal to sin 0 is 0. Therefore, y4 of 0 is equal to minus 2. 3 minus 1 is 2. Transform this 2 to RHS, you get minus 2. Now write Maclaurin series and substitute. Write Maclaurin series up to 4th degree and then substitute. Y of 0 plus x into y dash 0 plus x square divided by 2 factorial into y double dash 0 plus x cube divided by 3 factorial into y triple dash 0 plus x power 4 divided by 4 factorial into 4th derivative at x is equal to 0. Substitute. Y of 0 is 0 plus x into y dash and y dash is 1. Therefore, x into 1 is x plus x square by 2 factorial into y double dash and y double dash is minus 1. plus x cube divided by 3 factorial into y triple dash, and y triple dash is 1, plus x power 4 divided by 4 factorial into 4th derivative is minus 2. This is equal to x plus into minus minus x square divided by 2 factorial is 2 into 1 2, plus x cube divided by 3 factorial is 3 into 2 into 1, that is 6, plus into minus minus x power 4 divided by 4 factorial is 24, 2 by 24 is 1 by 12. This is the series. Make a note of this. Is over?
Yes, sir.
Okay. Next. Obtain the Maclaurin series of log 1 plus tan x up to the third degree term. That means you have to differentiate successively 3 times with respect to x up to third degree. The given function is log 1 plus tan x, let it be y of x. Put x is equal to 0. When x is equal to 0, this will be y of 0. And this is equal to, here tan 0 is 0, 0 plus 1 is 1, therefore we get log 1, and log 1 is always equal to 0. Next, differentiate y of x is equal to log 1 plus tan x with respect to x. Derivative of y is y1. Derivative of log 1 plus tan x is 1 over 1 plus tan x. Into derivative of 1 plus tan x, where 1 is a constant, its derivative must be 0, and derivative of tan x is secant square x. Therefore, we get secant square x divided by 1 plus tan x. Put x is equal to 0. When x is equal to 0, this will be y1 of 0. y1 of x will be y1 of 0. Secant 0 is 1, 1 square is 1, divided by, here tan 0 is 0, 0 plus 1 is 1, and 1 by 1 is 1. y1 of 0 is equal to 1. Next, to find second derivative, first we shall simplify this. 1 plus tan x into y1 is equal to secant square x. 1 plus tan x into y1 is equal to secant square x. First we shall differentiate this part using product rule, treating this as first function and this as second function. 1 plus tan x first function into derivative of y1 is y2, plus second function y1 as this into derivative of 1 plus tan x, where 1 is a constant, its derivative must be 0, and derivative of tan x is secant square x. This is equal to derivative of secant square x is 2 secant x. Derivative of secant x is secant x into tan x. Therefore, 1 plus tan x into y2 plus secant square x into y1 is equal to 2 secant x into secant x is secant square x into tan x. Now put x is equal to 0. When x is equal to 0, this will be 1 plus tan 0. Tan 0 is 0. 0 plus 1 is 1. 1 into y2 is y2. y2 means y2 of 0. Here, secant 0 is 1, 1 square is 1 into y1. y1 is also equal to 1. Therefore, 1 into 1 is 1. This is equal to, here tan 0 is 0, 0 into anything is 0. Therefore, y2 of 0 is equal to minus 1. y2 of 0 is minus 1. Next, to find third derivative, we differentiate this expression with respect to x. 1 plus tan x into derivative of y2 is y3. Right? This is first function and this is second function. First function 1 plus tan x into derivative of y2 is y3 plus derivative of 1 plus tan x. 1 is constant, its derivative must be 0, and derivative of tan x is secant square x into second function y2. Similarly, we differentiate this, treating secant square x as first function and y1 as second function. First function secant square x into derivative of y1 is y2 plus second function y1 into derivative of secant square x is 2 secant x into derivative of secant x is secant x into tan x. This is equal to 2 into 2 is constant, keep it outside. Now secant square x is first function and tan x is second function. Secant square x into derivative of tan x is secant square x plus tan x into derivative of secant square x is 2 secant x and that of secant x is secant x into tan x. Now put x is equal to 0. When x is equal to 0, this will be tan 0. Tan 0 is 0. 0 plus 1 is 1. 1 into y3 is y3. y3 means y3 of 0. Secant 0 is 1. 1 square is 1 into y2 and y2 is minus 1. 1 into minus 1 is minus 1. For the same reason, this is also minus 1. Secant 0 is 1. 1 square is 1 into y2 is minus 1. 1 into minus 1 is minus 1. Here tan 0 is 0, 0 into anything is 0. This is equal to 2 into secant 0 is 1, 1 square is 1, this is also 1 square. 1 square into 1 square is 1. And here tan 0 is 0, 0 into anything is 0. Therefore, y3 of 0 is equal to 2 into 1, 2. Minus 1, minus 1, minus 2, transform this minus 2 to RHS. 2 plus 2 is 4. y3 of 0 is 4. The rest is very simple. Write the formula and substitute. Write the formula up to third degree, that is y of 0 plus x into y dash 0 plus x squared divided by 2 factorial into y double dash 0 plus x cubed divided by 3 factorial into y triple dash 0. Y of x is log 1 plus tan x and y of 0 is 0 plus x into y dash is 1. Therefore, x into 1 is x plus x squared divided by 2 factorial into y double dash is minus 1 plus x cubed divided by 3 factorial into y triple dash is 4. Or this can be written as x plus into minus minus x squared divided by 2 factorial is 2 plus x cubed into 4 divided by 3 factorial. 3 factorial is 6. That means 4 by 6. 4 by 6 is same as 2 by 3. For your doubts, you can unmute and ask. Yes, sir.
Yes, sir. Yes, sir.
Okay, let's move on to next one. Obtain the Maclaurin series of e power x into sin x up to fifth degree terms. That means you have to differentiate successively 5 terms with respect to x up to fifth degree term. Let this be y of x. Y of x is equal to e power x into sin x. Put x is equal to 0. When x is equal to 0, this will be y of 0. E power 0. E power 0 is 1 into sin 0. Sin 0 is 0. Therefore, y of 0 is equal to 0. Next, to find first derivative, we differentiate this. Derivative of y of x is y1 of x. Here e power x is first function, keep it as this. Derivative of sin x is cos x plus sin x into derivative of e power x is e power x itself. Here e power x is common in both the terms, keep it outside. Then what you get within the brackets is cos x plus sin x. E power x into cos x plus sin x. Now put x is equal to 0. When x is equal to 0, we get y1 of 0 is equal to e power 0 is 1 into cos 0 is 1 plus sin 0 is 0. Therefore, this is equal to 1 into 1, 1. Y1 of 0 is equal to 1. Next, to find a second derivative, you differentiate this expression with respect to x. To find y2, we differentiate y1. Derivative of y1 is y2 of x. Here e power x is first function, keep it as this. Differentiate second function. Derivative of cos x is minus sin x plus derivative of sin x is cos x plus second function cos x plus sin x into derivative of e power x is e power x. This is equal to, here e power x is common in both the terms. What you get within the brackets is minus sin x plus cos x plus sin x. This minus sin x will get cancelled with this plus sin x. You get cos x plus cos x, 2 cos x. Y2 of x is equal to e power x into 2 cos x. Now put x is equal to 0. When x is equal to 0, this will be 2 into e power 0 into cos 0. That is, y2 of 0 is equal to 2 into e power 0 is 1 into cos 0 is also 1. Therefore, this is equal to 2. Y2 of 0 is equal to 2. Next, we find y3. Meanwhile, you mark your attendance. Mark your attendance. To find y3, differentiate y2 with respect to x. Here 2 into e power x is first function and cos x is second function. Derivative of y2 is y3. Y3 of x is equal to 2 into e power x is first function, keep it as this, and the derivative of cos x is minus sin x plus second function cos x into derivative of 2 into e power x is 2 into e power x itself. This is equal to, here 2 into e power x is common in both the terms, keep it outside. What you get inside is cos x minus sin x. 2 into e power x into cos x minus sin x. Put x is equal to 0. You get y3 of 0 is equal to 2 into e power 0. E power 0 is 1, 1 into 2 is 2 into, here cos 0 is 1. Sin 0 is 0. Therefore, 2 into 1 is 2. We get y3 of 0 is equal to 2. Next, we find y4 and y5. To find y4, we differentiate y3. Derivative of this y3 is y4 of x. Here 2 into e power x is first function, cos x minus sin x is second function. 2 into e power x into derivative of cos x minus sin x. Derivative of cos x is minus sin x, minus sin x is cos x. First function into derivative of second function, plus second function cos x minus sin x into derivative of 2 into e power x is 2 into e power x itself. Here 2 into e power x is common in both the terms, keep it outside. Then what you get within the brackets is minus sin x minus cos x plus cos x minus sin x. This minus cos x will get cancelled with this plus cos x. Minus sin x is minus 2 sin x. This is equal to minus 2 into 2 is minus 4 into e power x into sin x. Minus 4 into e power x into sin x. Put x is equal to 0. When x is equal to 0, the expression will be y4 of 0. y4 of x will be y4 of 0. And here sin 0 is 0. 0 into anything is 0. y4 of 0 is 0. Again, you differentiate y4 to get y5. Derivative of y4 is y5. This is equal to, here first function is minus 4 into e power x. Keep it as it is. Into derivative of sin x is cos x. Plus second function sin x into derivative of minus 4 e power x is minus 4 e power x as it is. Put x is equal to 0. You get y5 of 0 is equal to minus 4 into this one. Minus 4 into e power 0 is 1, cos 0 is 1. And here sin 0 is 0, 0 into anything is 0. Therefore, y5 of 0 is equal to minus 4. Rest is very simple. Write the formula and substitute. Mark your attendance along with admission number. Admission number is compulsory, without which we cannot update your attendance. Prajwal DV. Mention your admission number. Prajwal. Bharat S. Faisal Ahmad Khan. Mention your admission number. Meghana SN. Otherwise, your attendance will be marked as absent. Akshata AP. Mahant KP. Shannon Akanksha. Hemant CG. Those who haven't mentioned admission number, please mention here. Otherwise, your attendance will be marked as absent. Rachana KP. Raksha HG. Amruta VM. Apeksha G. Inchara HK. Is this over?
Yes, sir.
Next. Expand e power a into sin inverse x. in ascending powers of x. Degree of the expansion is not mentioned. We expand it up to third degree. Okay, expand it up to third or fourth degree. It is actually not mentioned here. Degree of the expansion. We mention up to third degree. That's enough. The session will be terminated now. I'll rejoin within 1 or 2 minutes. Please wait.